Loic, you want to run through an erasure coding update, and then maybe you or
Sure.
Veronica can discuss what's going on with the Google Summer of Code project and anything else that may be tangentially related.
Sure. Since currently I can speak clearly as long as nobody talks to me. That's weird. So a few items regarding tautology. The way Erasure code profiles were supported initially was kind of bizarre because there were no profiles initially, etc. So there is a pending pull request that adds support for generic Erasure code profiles, which would allow to define jobs for the QA suites for locally repairable codes or any kind of variations of parameters that we like. So this is for the QA thing. Then there seems to be work to be done regarding Erasure code plugin optimization. So far, I focused on stabilizing the Erasure plugin and doing some benchmarking to know how much throughput we can have. But I did not do any work on trying to figure out if we could optimize something, if something was not performing well enough compared to what it could, because the measures, the performance that we get are good enough for now. So this is an area where we could do something, I guess, fairly easily.
And I'll interject something really quickly here. I
sure.
think one of the, I think on Intel processors, in general, Erasure does really well. And there's also the Intel stuff that you'll mention in a minute. But the big question for me is what happens when you're on ARM processors. I think it's especially relevant when you look at the Ethernet drives that are sort of on their way to market, where you're going to have these tiny little ARM processors on the disk that are acting as OSDs, and you want to use them for cold storage that's erasure coded, then having Erasure work well on ARM or something like Erasure have a ARM, something that uses the ARM accelerated instruction set or whatever vector would be good.
I wonder if any small end machine have these Neon processors. I guess they are the one with the SIMD capabilities. But in any case, I would be very curious to see benchmarks of how it behaves on ARM, because I guess it will not be very fast, but we need to know if it's fast enough.
Anyway, if there's anybody who's listening who's, somebody who knows about ARM should chime in today or on the list or something.
Do we have ARM machines somewhere?
We do. We have a bunch of we have a couple boxes full of ARM processors in the lab, and
cool.
We hope to get some prototype Ethernet drives in sometime soon too, although it hasn't happened yet.
Well, there is a
generally available for.
Okay, there is a pending pull request for a benchmark where you have HTML page, which is the result of the comparison of the benchmark between various parameters for the plugin. So we could just run that and see what comes out of it. Mm-hmm. That should be quick.
Cool. Yep. Cool. Okay.
That's amazing. I can hear you fine now. Yeah. There also is the question or more information about the maintenance and contribution to Erasure and AF Complete. So at the moment, we have a copy of the stable branches for each of them in the Ceph namespace on GitHub, and they exactly match the latest stable version. So we were diligent in pushing back whatever we needed to for Ceph to work over there. There still is one pull request, but it's in Ceph that is being tested. It's ticket 8071 regarding a minor change in the way we initialize JF complete. But we're in sync with their latest stable version. Yeah, that's it. There is the locally repairable code. I added a link to the benchmark that I just talked about. I did the benchmark, but I did not analyze the call graph to figure out exactly why there is such a big difference between 4K and 1 megabyte encoding decoding. There is a significant difference. It shouldn't be so large. I guess we're doing something backward, but it's still good enough, so I did not really worry about it. And then if Andreas is here, maybe he could talk about his prototype plugin for ISA-L. Andreas, how are you around?
Yes. Do you hear me? Hello? Okay.
Yes.
Hi, Seth. Yes, I just today had contact with the developer of the ISA-L library. So in principle, I implemented the plugin. This is even a little bit faster than the Erasure if you have a modern Intel CPU. There was just one question with the decoding of coding chunks, but he in principle answered me how to do this efficiently. So there's not much missing here. It's just not clear also there how you want to package this. Because this library comes either as a static one or a shared library. And the question is if you want to compile this in the repository, you just DL open it as a shared library, what I do for the moment. It's more a packaging question. The implementation is actually straightforward. It's very similar to the Erasure one.
I would lean towards static just because it's simpler, but I'm not sure it matters. I mean, the plugin itself is dynamic, right? The EC plugins, so you could statically link it into that dynamic thing. Otherwise, you have to worry about it. Until the distros are like packaging up ISA-L in a nice, tidy, generic way. Yeah, I lean towards static.
Okay, just that it has similar issues like the Erasure one. If you don't have the right support, then you have to, for every extension, you have to build a different plugin. But okay, if you want this way.
Yeah.
I mean, this library has some small advantages because in principle it has no alignment requirements, so you can just go to byte alignments. But for sure, for the performance, the developer told me that 64-byte alignment is okay. So there's also a question one has to decide if one wants to align to 64-byte or have very small objects. Yeah, and one more thing is I discussed already with Loic because in principle this plugin shares a lot in the code base of the Erasure plugin. So in principle they should derive from some generic one to avoid duplication of code.
Yeah, well, it's part of a larger pull request. Yeah, it will help.
Okay.
Okay.
I mean, would it make sense to wire this into Erasure upstream then? Like, just make Erasure?
I don't think so.
Call it? No.
No.
Okay.
It's competing.
Yeah.
I don't think that
Yeah.
fits into.
Yeah. Okay.
But
Okay.
you could add it into as a method in your Erasure plugin, and don't call it Erasure if you want. That would be much simpler and save a lot of duplications. But probably
Yeah,
for other
but
reasons, it's not good to do this.
for LRC anyway, there has been factorization of the common parts between the two, so it wouldn't be so much duplication.
Okay. How far along is this? Like, is it working? Is it just a proof of concept at this point? I mean, how close is it from being in a state where we can actually merge?
You mean me or like?
You for the
he means
Intel
you,
ISA.
yeah.
No, it
ISA
works.
library version, yeah.
It's complete. It works. You can try it if you want. So I've
Okay.
made a plugin which is compatible with Firefly, and I mean the encoding is like 10, 15, 20% faster, and the decoding, if I get now this patch right, will be the same speed. So eventually I've seen that for this 4K encoding you do, it's really significantly better. I don't know why, but I mean this is good news.
Yeah, that's awesome. Okay. So I think then I think the work then is just to figure out how to embed the ISAL piece, which I guess it's already there. Yeah. So I'm looking at the source tree in your Git tree. That's assuming that the library there's a shared library installed on localhost. Is that how it works?
Yes, because I didn't want, because they have a very weird makefile, so
Yeah.
I didn't want to
Yeah. So I
rewrite their makefile. So.
think ultimately that's the hard part because we don't want to like make a separate set of distro packages. It's much simpler to statically link it in. And honestly, that's sort of what Intel, from what I understand, what they generally expect to. They don't really. I mean, their normal audience for these things is, you know, EMC or whatever who's making their next appliance, and they're going to pick the specific one that runs on the model of processor that,
yes,
whatever, anyway, that they're using in their appliance. But yeah, would love to get this into the tree.
okay.
Cool.
Maybe we only have a few minutes left.
Yep.
Veronica, are you connected? Hello? No. Well.
Yeah, she sounds like she's here, although not on voice.
Hello? Do you hear me?
Oh, yes.
Yep.
Yes.
Okay.
Can you give us maybe a short update about reliability model and Erasure code?
Well, yes. So, well, first I start working with the GUI of the application because it was a bit confusing. Now I'm trying to implement the Rados erasure code based on the assumptions that the current model has for replication. I found a bit confusing how to calculate the time for repairing. I exchanged some emails today with Kyle, and yeah, I also found this tool for benchmarking erasure code that maybe it may help to estimate the time of repairing, but I didn't have time to check that, so I will try it, tomorrow to run this tool, and yeah, probably I will contact Loic to understand more about that.
Sure, whenever you want.
The other thing, so the assumptions of the current model, I found them very basic and not realistic, but still I guess it is better to continue with these kind of assumptions and get some work and then try to move to other more realistic models. But yeah.
There was a question in the channel asking what tool you found for benchmarking for erasure codes.
There is there is a blog from Loic that is talking about a benchmark tool. I don't know. I didn't use it yet. But
Yeah,
he's
there is one. It's in the Ceph tree itself.
Okay.
That captures primarily the CPU overhead of the encoding, though, right?
Sorry, come again?
What?
That captures primarily the CPU overhead, right?
Yeah, it's just benchmarking the plugin itself and the CPU, and nothing about network.
In many systems, that will be not dominant or even negligible. Just,
Yeah.
Yeah, so then it may not help. Yeah.
Yep. Just a quick aside. I think that benchmarking patch is still sitting in a pull request awaiting a final merge, right?
Yep.
Yeah. Okay.
Well,
We should merge that.
The display. The pull request is about comparing and displaying, but the tool to do the benchmark itself is already in the Ceph tree.
I see.
Only
Okay.
it's not very human readable, but it's machine consumable.
Got it. Okay. Okay.
Cool. Is that pretty much everything from the Erasure coding world, Luke?
Yep.
Excellent. All right. Well, that brings us to the end of this session. So I think the next one we have here is a discussion on the cold storage pools. So let me get the video flipped over, and we'll get going there. Thank you both, Loic and Veronica.
Thank you.
Thank you.